G'day. In this video we're going to prepare for the task in week 6. The task in week 6 involves some geometry proofs, so it's handy if we run through our geometry rules even if we think we know them. Things like straight angles equals 180 degrees, one revolution is 360 degrees, vertically opposite angles are equal. Now remember, they're called vertically opposite angles, but you can just as easily have two angles that they're talking about that are horizontal. If they're two straight lines, then those two angles I've marked there with arcs are equal, but also the dots in the more vertical positions are also equal. Parallel lines, the three rules you'll recall are based on parallel lines cut by a transversal, and you've got three versions of those. Let's just check them out. Pretend I can draw properly. Okay, so here we have these two alternate angles on parallel lines are equal. We've got let's go corresponding. This one here and this one here are in corresponding positions on the parallel line, and corresponding angles in parallel lines are equal. And kind of like the exception to the rule, we have co-interior. So this one here and this one here, they are co-interior, that's a C, co-interior angles are what we'd call supplementary, which means they add up to 180 degrees. Sounds good. So that's our parallel line rules. Let me just pause there and we'll continue on in a sec. Now just checking out our types of triangles to remind us. We've got equilateral triangle with 60 degrees in each angle. Isosceles triangle, you've got markings to say that two of the sides are equal. But of course, if two of the sides are equal, that creates two base angles that are the same as each other. For a scalene triangle, that's a triangle where none of the sides are equal to any of the other sides. So we'd indicate that by putting a mark on one side, two markings on the other, and three markings on the third side to indicate that none of those sides match each other. Moving on to angle sums, you'll recall that the angle sum of a triangle is 180 degrees. And an angle sum of a quadrilateral, any sort of quadrilateral really, is 360 degrees. So when we follow that pattern, there's a rule for angle sums, and the angle sum equals, angle sum of a polygon equals n minus 2, now n is the number of sides of the polygon, times 180 degrees. So that's the angle sum of any polygon. Whether it's a 10-sided figure, you'd put a 10 in for the n and work out the angle sum. So we've got angle sum happening there. Now if we want to find the size of each angle in a regular figure, now a regular figure has the same length side, so it might be like a square is a regular quadrilateral, and you might have a regular pentagon, if I can draw properly, where all the five sides are the same length. In that situation, we can find the size of each angle by finding the angle sum using the formula we just described, and dividing by the number of sides or the number of angles they're going to match. So for a pentagon, for example, we might find there are 5 sides, so we got 3 lots of 180. Angle sum is 540 degrees, and there are 5 angles, so each angle would be 108 degrees. That might come in handy sometime. Okay, just to finish off our angle sum type stuff, we have a situation where we have exterior angles. Now I'll mark the exterior angles of this triangle here with red. It's like we're extending each of the sides and creating 3 outside type angles there. And in the quadrilateral, you can see I've extended the lines and I'm marking in the exterior angles here. And in a weird way, no matter what shape we